Hello, welcome back to our channel. So in this module, we are going to explain to you after creating a schematic usually is a practice that you perform a simulations. You check for the electrical rule check whether you have taken the proper components and the devices have made their connections properly. So in our previous modules, we have explained to you those stuff like how to perform the ERC, how to pick up the components from the library and devices, how to interconnect them, and after performing ERC without error or warning, we demonstrated you how to perform the basic simulations. Now in this module, we will teach you and train you about how to transition from schematic to the PCB. We are not going to tell you the details about the PCB designing and all. Rather, there is a common error that one may encounter. So there will be a couple of stuffs or a couple of things we will be sharing with you when you transition from schematic to the PCB. So after creating the schematic, you have placed all the devices, components, and the voltage sources, such as these are the power supplies to the circuits, that is VDD and the VSS, and this is your input source, and this is a circuit of differential pair. So usual practice is that, let's say this circuit is complete and you want to make a PCB out of it. So what you do is you go for tools, and there is an option about switch to PCB editor, and there is one more option, update PCB from the schematic. So if we click the one, or alternatively you can press F8 button on your keypad of the computer or laptop. So I press here. Once I click that button, look at this PCB board is being loaded, and I have this box which reads update PCB from the schematic. There are some options that I have checked in. So I have unchecked all these options, or maybe I can choose these to check these options also depending on that. Now look at this instruction here that reads changes to be applied. So let me scroll this up. So it says that the processing symbol Q1 package, I have a two transistor Q1 and Q2. So there are packages from the libraries we have used. Then it is processing registers RC1, RC2, RC3, and it is processing symbols for the three voltage sources. Two voltage sources are for the power supplies of the circuit, and one is the input voltage source to the differential pair. Now it is adding footprint for the transistor Q1 and Q2, but there is an error. It reads it cannot add RC1 because there is no footprint assigned. So we forgot to assign a footprint to that one, right? So if you just take the symbols from the library and it doesn't have any footprint, then this error will be highlighted in the PCB editor. And same is for RC2, same is for RC3. We have three registers, remember, and three voltage sources. So therefore we'll have total 6 errors. There is no warning though. Let us check these options and we'll see if there is some change that comes over here. No, we still have 6 errors and 0 warning. We'll update the PCB by clicking this one, and we'll just do that and again update the PCB. And it so we have to get rid of these 6 errors. So I will show you how to do that. Meanwhile, you can have a look at the two transistors that have been placed. So let me zoom to objects. For example, I am actually uh, let us do that. Let us click, that is home, and maybe here is better. Then I will take this span. Okay, just a second. So let me just escape and then select this portion, and then maybe I have to move it in the center of the screen, for example. So now I can do that right here, and then I will zoom to objects. So look at these two transistors, BC547 and BC547, these symbols. These are the symbols that I had actually stretched. So I will just get them back to their respective transistors nearby. So I think we have in the schematic 3 resistors, 3 voltage sources, but we don't really have all those representation when we switch to the PCB board, because we have got 6 errors. So we'll now see how to get rid of those 6 errors. When you will do that, you might also encounter that one. So let me close this. Let's say don't save it, discard changes, and we are back to our schematic screen. So the first thing is we want to assign the footprint to the register. So what we will do, double click here. So it opens the symbol properties, and from the symbols properties, actually, we can actually get this one. So let me show you that. Look at this, there is no footprint assigned right here, otherwise there would have been this instruction. In another way, I want to show you for the transistor, because these are the manufacturer parts and these are the ideal registers we have used. So you need to use the practical registers actually. So here you might have double click it and you will see there is a information about the footprint that is there. There is a information about data sheet and the manufacturer. There is a library, there is a model. We have done all this. I have explained to you in the previous module how to do this, and this information is needed when you are doing the simulations and when you are doing the of PCB, right? So that's why, because we had a footprint for the transistors, it reflected into the PC board. So click simulation, and now we have to find how to do that. So I will click to tools, and there is an option here, assign footprint. So after that, you look at this box opens up and it shows me that for a symbol of Q1 and Q2, which are BC547 transistors, and they have their packages and the footprints are being assigned to that. So what is the footprint for the transistor Q1 here? That is the package TO inline. This is the footprint that got assigned. If I double click it, there is nothing. But what if I double click here? So it actually it doesn't show me. Right clicking over it, I can select the view selected footprint. So here is the footprint for that transistor. You see that? Now same, I right click here and view select this transistor's footprints. Now there is an option also, delete the association. If you don't want a particular footprint to be associated with the symbol of that component or a device, you can choose this delete association option. But now, coming back to our discussion, we have 3 resistors, 3 voltage sources, and for registers value of 10 gauge, we don't have a footprint. So what I'll do, I will click here and I need to assign the footprint. So here, where is which library I should use? Obviously, I will choose the library of register. So let me select here and press R on my keyboard. There is nothing happening. So let me find out how actually I can do that. So if I have an option about that. So there is this battery button, calibration, um, connector wire, crystal here. Okay, there is this one. So if I click the register, actually, there is nothing happening. If I right click here, view selected, I don't have any footprint. See, there is this one. And let me just click on selecting this. So you have inductor package. Now look at this. You have register SMD or through hole. So it depends on which kind of register you want. For example, I want to choose the SMD. So there is, once I select the any one option in the right side, you see those footprints are being reflected. Look at that. I choose a particular library and that's reflected. So let's say I go to register SMD, and for the RC one, now I have to choose this one. For example, this particular footprint, this or this one. So there is a size also depending on what register I want. So there are the pad sizes. There are different pad sizes available in the market. So for example, I have chosen this kind of footprint for the RC1. So let me select that. Look at this one. Okay, for the RC2, I will choose the same one. For the RC3, let me see that. For the RC3, I will choose the same one. So depending on what you want, you can choose that, or you can choose any other footprints. Okay, now why am I not going to choose the footprints for the voltage source? Look at this. Voltage source are the symbols, and they are not devices or the components or the integrated circuits. They are just symbols, and in PCB, we don't want their footprints. So we will leave it like that. But if we leave like that, and because we don't want to assign a footprints, so accordingly it will still reflect an error. Three errors will be gone because we have chosen the register footprints now, but out of six error, three will remain. But we don't want footprint, however. So I will show you how to solve that. So after selecting the footprints for the registers, we already have footprints for transistors. Click apply, save schematic and continue. Say here, and then click OK. And we will now zoom to objects. So we are back here. Now look at this. If you double click here, you got the footprint for the register, which is we have selected. This is the reference, that's the value, and the data sheet is not there because we are not using any part from the manufacturer, but we have the footprint. So we can use register from any manufacturer as long as we meet the value and some other specific details. Click OK. What about this register? We have this also. Okay. And what about this registers? We have this register also. Okay. So we have got that. And update symbol from the library. We don't want to use this option, but let me right click here. And if I show you the properties, I will go again to the same block here, and that's it. So here is the edit symbol option, edit library symbol option. You can explore all those parts. So depending on what kind of registers you have used for the simulation and the schematic. Okay, I will close it. But before that, let me show you how the footprint looks like. So assign footprint again, and for the register, right click and select view selected footprint. So look at this. This is how these are the pads of the registers actually, and this is how you will place that registers. Okay. Let me choose the different register maybe. For this, I will choose this one, for example, and this is now show the view selected footprint, and this is how it is. And for the third one, again view selected, and this is how it is. Okay, so we have done that, and we have seen how the footprints looks like. So we'll just click apply and click simulations. Coming back to schematic, zoom to objects. Now what to do with voltage source, but let me just go to tools, update PCBs from schematic, and we'll see if the errors have gone. And yes, we have got only three errors now. It says there is no footprint for the voltage source V1, V2, and V4. But for the registers, we have got these changes. Add RC1, footprints, and RRC2 footprints and add RC. So your tool KiCAD has added the footprints for both the transistors and the three registers. Okay, after processing on that. So update PCB. Let me uncheck that. We don't want anything. Update PCB. So there is no impact actually. Okay, close it here. Look at this PCB component. So we've got all the devices. Let me click zoom to object. So there are some interconnection wires also here. There are interconnection wires. So based on how the devices Q1 and Q2 and the components are registers are connected to each other. So we've got this. So the objective of this video is not to teach you how to do the PCB drawing. That will cover in some other sessions later. But the objective of this video module is to explain to you how to get rid of errors that you will when you transition from schematic to the PCB. And these are the most common errors. I encountered these errors when I used the first time KiCAD, and it took me about 1 hour to solve these problems and solve these issues. And with that knowledge, this is a ready-made video for you all to refer to it directly and get going with your electronic circuit and system design. So now we'll close the box, but we still have 3 errors. Discard changes. What about this? Look at this. These components have been highlighted in the schematic. Now look at these 3 voltage sources. So what I'll do, I will just double click on each voltage sources. There are attributes. Exclude from simulations, exclude from bill of materials, exclude from board. So it's like when you actually generate the bill of materials, which is useful for adding symbols for board footprints such as logos and all, that you don't want to appear in the bill of materials exports. You don't want voltage source information to be reported in the bill of material. You just want information about the devices and the components. So you just click here. But that is also not going to solve the problem when it comes to PC board. Here is that instruction. We'll check that. This option is useful for adding symbols that only get exported to the bill of materials, but not required to the layout the board. Not required to lay out the board, such as mechanical fasteners and enclosures. So we don't want the footprint for the voltage source, as I explained before. So I will check that out and I will then click OK. So this is done for it. I will do it for similarly for other voltage sources. I will also check these options. So look at this. And once that is done, you can save your schematic and go to tools. Again, check update PCB from schematic. And we are not going to have any error or warning. Boom, we are done with 0 errors, 0 warning. We don't have that. We'll keep checking these options if there is some error or something reflected. Look at these components have come here. Second update. Excuse me. Replace footprints with those with the schematic update. And we are successfully done with that. Close it. Look at this beautiful image of your register, transistor, and all those things. Okay, so let me just zoom, select that first, and maybe you will, oh, they're not coming here. Why not? So we'll just do that, and now they will come here in the place them in the center. Then check zoom to objects, and all these components are done, and all these devices are also done. And very good way we have managed to place all components and the devices. We have transitioned successfully from schematic to the PCB. And now it's up to you to explore all these layers, their interconnections, replacements, routing. That's a different part. We'll cover that, as I said, in some other sections, some other time. Okay, so close it and discard changes, and we are back here. Is there anything that I have left? So we have explained to you already the simulation of this circuit. So if you are new and first time here, refer to our previous modules. Don't forget to like and subscribe to our channel. Like this video, share it with others for a wider reach, so that all gets benefited with this free open source KiCAD, very effective tool for schematic drawing, simulations, and the PCB generation. Till then, stay tuned for more engaging contents like this, and wish you all happy learning.